LEGO Camp was a 2-week day camp that introduced children ages 10 to 14 to fundamental engineering and programming concepts. After advertising in the local newspaper, online media, and via word of mouth, the camp filled to its maximum capacity of 18 students. The camp was held in a technology classroom at our team's high school in North Brunswick, New Jersey from 12:30 to 3 p.m. for 2 weeks. Each day, the kids were introduced to a new engineering principle and then tasked with a new mission to complete. Using LEGO RCX bricks, LEGO Mindstorms programming, and a wide array of LEGO parts, the campers were empowered to turn their imaginative creations into physical realities. The first week was all about teaching the campers how to build a strong base and make their robots faster or more powerful. The campers learned how gear ratios could be used to build the fastest race bot one day, and then how the same lessons could be applied to construct the slowest and most powerful sumo bot the next. The second week focused on programming robots to complete obstacle courses and other tasks using a variety of sensors. One day, the obstacle course might require the campers to program light sensors to follow a black line or program touch sensors to navigate through a maze. Aided by Radar Robotix team members, the campers were able to explore and apply the basic laws of science, technology, engineering, and mathematics. The camp culminated in the final challenge, the Grand Obstacle Course, which required light sensors, touch sensors, and dead reckoning. The robots were required to sense a black line on the ground, which led to a ramp with a fairly steep incline. This required the campers to gear for power. The course concluded with a series of blocks that the robots had to detect using touch sensors. STEM stands for Science, Technology, Engineering, and Mathematics. Our LEGO camp emphasized each of these pillars and gave campers an understanding of why STEM education is so important. Science gives things an explanation or reason. It tells us why things are the way they are. The campers can apply the basic lessons of gears to the real world, understanding why their bike works a certain way or why a tank is as slow as it is. Technology embodies using the tools you have to solve the problem in front of you in some novel way. Each day, the campers combine LEGO bricks and code blocks in a unique way to enable their robots to overcome different obstacles or achieve some new functionality. We were constantly impressed with their clever solution. Engineering improves people's lives. Today, a camper is building a race car. Tomorrow, the camper could be the CEO of a car company that designs environmentally friendly cars. These children are the engineers of our future, and LEGO Camp is a way for them to get interested in engineering. Furthermore, engineers must work in groups to develop a solution to a common problem. LEGO Camp split the kids into 6 groups of 3, highlighting the importance of teamwork and communication. Math is needed for both programming and designing mechanical solutions. From determining how many wheel rotations it would take for their robot to travel a set distance, calculating gear ratios, or figuring out the geometry required for an arm, there was not a day that went by where a camper did not use math. LEGO Camp is kids having fun while building robots. It inspires kids to not only think about engineering in the future, but also to constantly think about how things work. It also makes them aware of the ways they can continue to pursue STEM-related activities. For example, many of the campers will become involved in FIRST by joining one of the many local FLL, FTC, or FRC teams. Several members of our own team are proof of this program's success, having participated in LEGO Camp before joining Radar Robotix. We also invited all of the campers to attend Brunswick Eruption, which is a one-day off-season FRC competition held at the same high school. Students that go through the FIRST program are twice as likely to pursue STEM fields in the future. They go on to work for companies like Google and NASA, or become inventors like Dean Kamen. We hope that we've guided and inspired these 18 bright young kids to pursue engineering in the future, and we hope to keep doing that for the years to come.